right, guys, we're on 5.6 half angle identities. Half angle identities, we're going to kind of briefly go through where it comes from. You would use the cosine sum identities to derive the half identities. So cosine sum tells us with double angles, we have cosine of 2x equals 1 minus 2 squared x. So if I wanted to substitute in 2 sine squared x, we would isolate, substitute in, keep going, all of that, and you get to the end. I know you don't really care how it got there, but here's the reason why it works. You do the same thing for tangent, get to the end, and then it creates your 5 final half angle identities. So these are your final identities. I'll give you a chance to write them down. Here we go. So first off, we have find the exact value of 15 degrees using the half angle. So how this is beneficial. When you think of a half angle, it's to help you use your unit circle values. So is there a value on our unit circle that if we divide it in half will equal 15? 30. So we will let A equal 30. So we would rewrite this as cosine of 30 divided by 2. So in this case, our A equals 30. And then we're going to just simply use the formula and plug it in. The first one? The first one, the cosine formula. So when we substitute in, we get plus or minus the square root of 1 plus cosine of 30 degrees divided by 2. What's the cosine of 30 degrees? So we have 1 plus square root of 3 over 2 divided by 2. We're going to clean this up. In order to clean this up, you have to have one fraction in the numerator, and then we're going to keep, change, flip. So on the side, we're going to do 1 plus the square root of 3 over 2. I'm going to chopstick it out. 1 times 1 is, 1 times 2 is 2. 1 times square root of 3 is square root of 3. All over 2 is 2. So that gives me plus or minus the square root of 2 plus the square root of 3 over 2 divided by 2. Okay, how do we divide fractions? We keep, change, and flip it. So we're going to keep, change, and flip. So we have 2 plus the square root of 3 times, instead of 2 over 1, it becomes 1 over 2. And what does that make? We end up with 2 plus the square root of 3 all over 4. Okay, so our final answer is I can take the square root of 4, but can I take the square root of the top? No. So our final answer will be plus or minus the square root of 2 plus the square root of 3 all over 2. Because the square root of 4 is 2. And that is our exact answer. So the same thing. Just with another formula. That's the exact value of cosine of 15 degrees. So this equals the cosine of 15 degrees. And it's going to be positive because it's in what quadrant? 1. All right. Questions about example 1? Okay. Now, oh, my knee popped. We have the tan of 22.5 using the identity tan A over 2. So thinking about our unit circle, what value on our unit circle can I divide by 2 to get 22.5? 45. So for this, we know that A equals 45. Yes? So we're going to plug in 45 for A. So we get sine of 45 divided by 1 plus cosine of 45. What is the sine of 45? Square root of 2 over 2. What is the cosine of 45? So again, we have fractions within a fraction. Before we can keep, change, and flip, we have to have a common fraction, a common denominator, a combined fraction, a combined fraction. So we would do 1 over 1 plus square root of 2 over 2, combine it, and we get 2 plus the square root of 2 all over 2. So the square root of 2 over 2 divided by 2 plus the square root of 2 over 2. Now that I have a fraction in the numerator and a fraction in the denominator, it's not in the square root. That's not under the square root. It's square root of 2 over 2. Here? Oh, because I combined. It was 1 times 2 is 2. 1 plus square root of 2 is square root of 2. And then 1 times 2 is 2. So now we're going to keep, change, and flip. So we get the square root of 2 over 2 times 2 over 2 plus the square root of 2. What happens to your 2's? They cancel out, and you're left with the square root of 2 over 2 plus the square root of 2. Okay, technically, this is not over, but I'm okay if you stop here. Can someone tell me why it's not over? Because there's a square root in the denominator, and you have to ratify it. I will quickly ratify it over here for you. When you're ratifying and there's addition involved, you have to use its conjugate, which means that instead of it being plus 2, I would multiply by 2 minus the square root of 2 over 2 minus the square root of 2. When I do that, I end up with 2 square in the numerator. You distribute, and I get 2 square root of 2 minus 2 in the numerator. And the denominator, 2 times 2 is 4. 4 minus, where are we at? And then square root of 2 times square root of 2 is 2, right? And 4 minus 2 is 2. And you can simplify, and you're going to be left with square root of 2 minus 1. I had to ratify to get the square root of 2 out of the denominator. So you have to. So when you're ratifying and you're multiplying, remember it's just the F and the L of FOIL. So the first times the first, the last times the last. The middle doesn't matter because it's going to do what? Cancel out. So it's just the F and the L of FOIL. So that gives you 4 minus 2, which is 2. All of these are factors of 2, so it reduces down to the square root of 2 minus 1. This gives you partial. This gives you full. Questions, comments, concerns? All right. Example 3, it says given cosine S equals 2/3 with 3 pi over 2, with S being between 3 pi over 2 and 2 pi, what quadrant is that? 4. You be in the 4th quadrant. So with you being in the 4th quadrant, cosine is positive, which means that negative and tan are going to be, tan and sine are going to be negative. So it says, can you find the cosine of S over 2 sine of s over 2 and the tan of s over 2. In order to do this, I need to know my sine value, because if you look at all these formulas, they involve what? Well, tan involves sine. So before we get started, bless you, we would have to find our sine. So if I have cosine is 2 over 3, that means that my x equals 2 and my r equals 3. How do I find my y? Pythagorean theorem. So we have 2 squared plus y squared equals 3 squared. So y equals 9 minus 4 and the square root of that. And that gives me what? Square root of 5. So y equals the square root of 5. So therefore the sine, again, is negative. And it's going to be negative square root of 5 over 3. So now I have the 2 main pieces to find everything else. I have cosine and I have sine. So the first thing we're going to find is our cosine s over 2. So the cosine of s over 2 equals, and we're going to use the formula 1 square root of 1 plus cosine a divided by 2. So we have plus or minus square root of 1 plus, and what is the cosine of s? 2 over 3 divided by 2. And we'll clean it up in a minute. Just want to make sure we can set it up. Now we're going to do the sine. So the sine of s divided by 2 equals, so using the sine formula, instead of 1 plus cosine, it's 1 minus, so plus or minus the square root of 1 minus, and the cosine of s is 2/3 all over 2. And lastly, we're going to do the tangent. And we're going to do the tan of s divided by 2 equals, and tan is either using sine a over 1 plus cosine a or 1 minus cosine a over sine a. Doesn't matter which one we use. Nope, we'll just use the first one. So we have the sine of a, and what's the sine of s in this case? Negative square root of 5 over 3 over 1 plus cosine of s, and what was cosine of s? 2 over 3. Okay, these give you partial credit because they're not simplified. Simplified means your goal is to use the least amount of characters. So I'm going to challenge you. I'm going to give you a moat to see how you can simplify. So your goal is to simplify, which means that you need to have one denominator, then keep, change, flip, right? One fraction in either the numerator or denominator, and then keep, change, and flip. So I'm going to pause and let you try. All right, so let's practice simplifying. So the first thing first is you have to have a single fraction in the numerator and the denominator, right? So this is going to lead me to equal the square root of, and when you're doing that, remember it's 1 over 1. You cross multiply the chopsticks in the bowl. So when I have 1 plus 2/3, that's the same thing as what? Anyone?
3 over 3 plus 2/3.
You're going to get, what'd you get? 5/3.
Yeah.
You should have gotten.
I thought you were saying like the process.
Yeah, so you should have got 5/3, right? When you're combining 1 plus 2/3, it's 5/3.
How do you get that?
So you have 1 over 1 plus 2 over 3. 1 times 3 is 3. 1 times 2 is 2. 3 times 1 is 3.
So you,
Yeah.
So you can't turn the 1 to 3 over 3?
Yeah, you can. I was showing her the shortcut.
Oh, okay.
Yeah, you could do 3 over 3. Yeah, all day long. So chopsticks. So chop 1 plus that one, and then all in the bowl. And that's how you would do a quick combine. Or like Andrew said, think of it as 3/3, and 3 plus 2 is 5. Common denominators. All right, now can I keep, change, flip? Yes, I can. Keep, change, flip. So when we keep, change, flip, we end up with 5/3 times 1/2, which gives us the square root of 5/6. Yes. Next one, we have the square root. So again, think about it as 3/3. What's 3 minus 2? 1/3. Now we're going to keep, change, flips. We have the square root of 1/3 times 1/2, which equals the square root of 1/6, which is square root of 6/6. Because can I take the square root of 1? Yeah, it's 1. So then you end up with square root of 6 in the denominator. Okay, now tangent, you have the choice to follow this, but if you already have your sine and cosine, could you also just use those values? Yeah, you could, right? You could always just use the values of your sine and cosine, or you can follow what's here. So we have negative square root of 5/3, keep, change, flip, times, and what's 1 plus 2/3? 5/3. And what's going to happen to 5/3? It's going to flip and becomes 3/5. And what happens to your 3's? And you're left with? And that is your simplified answers. Okay. The hardest part is not the plugging in, it's making sure you're comfortable with simplifying. Okay. Next practice. So we're going to do another. Do we need to practice more simplifying? This won't be on the test, but do y'all want it? This part won't be. Okay. So it says to simplify each expression. So if I have plus or minus, well, this would be on the test, I guess. 1 plus 12x/2 is just identifying which rule you're using. Which rule does this look the most like? The first one, right? Do we see it? So we would be using cosine of a/2. So for this problem, what is your a? A equals 12x. So if this is the rule that I'm following, then it becomes cosine of 12x/2, which equals what? So cosine 6x. This is on the test. Being able to figure out which rule you're following. That's it. Which one do I look like? Okay. All right. What about this one? Who do I look like? I look like tan a over. Do we see that? 1 minus cosine a divided by sine a. So your a equals 5 out. That's not an alpha. I wrote an infinity symbol. Let me try my a. My a is horrible. Okay. Trying to make the a, the alpha. I said I was trying. Like Andrew said, we're using which one? The last one. So 10, and our a is 5. Got worse. Can I simplify any more than that? So that is my answer. Yeah. All right. Last but not least.